This is part 3 of Unit 3, Lesson 4. This will be the final video for this lesson. So we're going to continue with the idea of taking derivatives of inverse functions and our log and exponential functions. So this last video has examples and then using a table as well. So we're going to start with example 7, and we're going to do the derivatives of each of these. Now, in the last video, we were doing all our exponential ones. These are our log ones, so just to review real quick, it's the derivatives of number 3 here. We're going to use these two derivatives here. The derivative of a log and then the derivative of a log with the chain rule. Okay, so the first one, we're looking for y prime of log base 5 of x. So this is straightforward, just using the definition that we're given. So y prime is going to equal 1 over x ln of 5. Okay, next one. Now we're going to be using the chain rule because we have the function sine x in the log. So y prime is going to be 1 over our ln of 3 times that base there, sine x, and then we're going to take the derivative of sine x, so we're going to multiply this times cosine x. Oops, I forgot the s. So y prime is going to equal cosine x ln of 3 sine x. Next one is the log of x plus 3 to the x. And again, we're going to have to use the chain rule here. So we're going to find y prime by first taking 1 over ln of 10, because we have no base shown, because that means it's base 10, multiplied times x plus 3 to the x. And then we're going to multiply that times the derivative of x plus 3 to the x, which is going to be 1 plus, and now we have to use our exponential definition, which will be 3 to the x ln of 3. So simplifying a little bit, making this look a little nicer, we have 1 plus 3 to the x ln of 3 over ln of 10 times x plus 3 to the x. Okay, now the next one I'm going to do two ways. I'm going to use the chain rule with the power rule, and I'm also going to do it using a log property, because this can also be rewritten as 1/3 log base 2 of 2x plus 1. So you don't have that third part of the derivative of the chain. So let's see how this goes. So doing it just the way it was given, y prime is going to be 1 over ln of 2 times the cube root of 2x plus 1, and then we're going to have to take the derivative of 2x, the cube root of 2x plus 1, which would be 1/3. Oops, let me write it this way. This is looking really messy. Hold on. Let me get rid of that line there. I'll put that line there when I need it. This is going to be times 1/3 2x plus 1 to the negative 2/3. So this becomes y prime becomes 1 over the 3 comes down. We still have our ln of 2, and now we have a 2/3 and a 1/3. So we're just going to have the 2x plus 1 there. Okay, so that's one way to do it. The other way would be using that form. So y prime is going to be that 1/3. Then we're going to have 1 over ln of 2. And then we have the 2x plus 1. And then we're going to have, oh, I forgot part of this here. I forgot to take the derivative of the 2x. So we're going to have a 2 there times the 2. So our final derivative will be, y prime will be 2 over 3 ln of 2 times 2x plus 1. And just to go back, right here, I forgot to take the derivative of the 2x, so that's where that 2 comes from there. Okay. Oops. All right, now find an equation of tangent line when f of x equals 6 to the x, where x equals 2. So it's exactly what we've done before, except the only difference is we're doing the derivative differently. So first over here, let me just find f of 2, because I'm going to need that y value. So that's just going to be 6 squared. So that's going to be 36. I'm going to need that when I write my tangent line. So f prime of x is going to equal 6 to the x ln of 6. So f prime of x is going to be 6 squared ln of 6. So f prime should be of 2. F prime of 2 is going to be 36 ln of 6. And if you're allowed to use, you could use this, or if you're allowed to use a calculator for this problem, this is approximately equal to 64.503. Okay, then finding the equation of tangent line, we have y equals 36 ln of 6 times x minus 2, and then we're going to have plus 36. Or if you're allowed to give a decimal approximation, this is 64.503 times x minus 2 plus 36. Both are correct, depending on which part of the test you are in. Okay, number 9. Bacteria is growing according to the function w of t equals 1.3 over 1 plus 0.3 e to the negative 0.4 t. That is a logistics function. So you should recognize the form of a logistics function. And this is true for t greater than or equal to 0, where w of t is the weight of the culture in ounces and t is in hours. Find the weight of the culture after 0 hours, 2 hours, and 8 hours. What is the limit as t approaches infinity? Okay, so we're finding those three to get an approximation of the way the limit would go. So we're going to substitute those t values in. So w of 0 is 1.3 divided by 1 plus 0.3 to e to the 0 power. So we're going to get 1.3 over 1.3. So this is 1. That one I could do without the calculator. The other two, I'm going to use a calculator to approximate those values. So I have 1 plus 0.3. And e is going to be to the negative 0.8. Because I'm going to take 2 times 0.4. And so that's going to be about 1.146. And then w of 8 is going to equal 1.3 over 1 plus 0.3. And then e to the negative 0.4 times 8. So that's going to be negative 3.2. And that's going to equal 1.284. So what do we see happening is that the limit as t approaches infinity of w of t is going to be our limiting value, which is the value on top of the fraction for a logistics function. That's your upper bound, is going to be 1.3. That's just a review of those, because sometimes they expect you to know that on the test. They'll give you a logistics function, and they'll expect you to understand, especially how to find the starting value and the limiting value. Okay, so our last example is with a table. So we're given a table, and we're supposed to use the table to find each of the indicated values, state the ordered pairs for the inverse function in the column provided. That's just to help you out here. So what we're going to do is we are going to switch our x and our g to give us our g inverse point. Now understand that f and g aren't inverses of each other. They each have their own inverse here. So f prime is going to be the inverse of f, and g prime are inverses. I'm sorry. Let me take that back. F prime is the derivative. G and g inverse are the inverses. So this is going to be 5, negative 3. The next point is going to be negative 1, 0. The third point is negative 3, 2. And the last point is 2, 4, because we're going to need those up as we go. So we want f inverse of 4 prime. So what we need to do is figure out what point goes with what f of x equals 4. And when we do that, we see that x is going to equal 2. So we are going to want to find this inverse derivative is take 1 over f prime of 2. So we have that value, f prime of 2 is 1, so we're going to have 1 over 1, which is 1. Okay, next we want g inverse prime of negative 3. So we're looking for where g of x equals negative 3, and we're going to see that's here, that's at 4. So here our x is going to equal 4. I'm sorry, I have the wrong value. It's not going to equal 4, it's here. Whoops. I'm looking at f there. Sorry, I apologize for that. Okay, so where g is negative 3 here, x is going to be 2. So x is 2 here. So I apologize for that. And so we're going to find g inverse negative 3 prime is going to equal 1 over g prime of 2. So this is going to equal 1 over, and our g prime of 2 is 2, so it's going to be 1/2. It's easy to get mixed up in those tables. Write the equation of the tangent line of g inverse of x when x equals 2. So we just looked through that, and we saw when x equals 2, we're in this line. So we have the point 2, 4 right here. 2, 4. So that's the point we're using. So for g inverse, we're using the point 2, 4. So that means that if we want the inverse of g prime of 2, we're going to have to do 1 over g prime of 4. Because remember, these will switch. So g prime of 4. So we go to 4 here, and we see g prime is negative 3. So our derivative is going to be 1 over negative 3, so it's going to be negative 1/3. So now we can write our tangent line is going to be negative 1/3 times x minus 2 plus 4. Okay, and then finally, we're supposed to estimate the value of g prime of 3, use the result to explain the behavior of the function of g when x equals 3. So what we want to understand, looking at the values we have in the table, we want g prime of 3, which isn't given, but we are given g of 4 and g of 2, and that's in between. So we're going to use a difference quotient to write this. So g prime of 3 is approximately equal to g of 4 minus g of 2 over 4 minus 2. So g of 4, I'm not going to scroll back up, you guys can look, is 2. G of 2 is 3, or negative 3, and then the difference between the x values is 2. So we get 5/2. So use the result to explain the behavior of the graph of g when x equals 3. So since g prime of 3 is approximately equal to 5 over 2, and that's a positive number, the graph, since the slope is increasing, the graph of G is also increasing. Just trying to tie together everything we've done so far. And this is the end of lesson 4.